Hello there, and welcome to an introductory session to Lewis Basics. My name is Osmar Soursour, and I'm a software engineer working at Microsoft Advanced Technology Labs in Cairo. And today we'll be talking about Microsoft's Language Understanding Intelligence Service, Lewis. Lewis is a service provided by Microsoft Cognitive Services, formerly known as Project Oxford. And they are a set of intelligence services with the vision of democratizing machine learning. So what does democratization mean in this context exactly? Well, in order to explain that, let's go back in time a few years, when building your own custom machine learned models would require assistance of data scientists who would then spend hours, days, and maybe sometimes years in order to build and customize machine learned models for specific domains. Now, with the introduction of Lewis and Microsoft Cognitive Services, you no longer need to be a data scientist in order to create your own machine learning models. Lewis leverages the wealth of Microsoft machine learning technology to enable you to add conversational intelligence to your application and build your own language understanding models specific to any domain. Lewis offers a set of language understanding tools to help you to do that, such as intent and entity detection, multi-turn dialogue support, action fulfillment, and many more. With Lewis's friendly UI, you can use those tools to create IoT experiences, virtual assistants, chatbots, or any intelligent service on any device. And today, I'll be showing you how to create that yourself. So let's get started by visiting www.lewis.ai and signing into our live account. Now, let's say I have a personal assistant on my device, and I wanted to understand travel-related phrases, such as book me a flight back to Cairo, or book me a flight to San Francisco on the 30th of March. So we'll start by creating a new application, and we'll call it Travel Agent. As you can see, Lewis supports English, Chinese, French, Spanish, and Italian. We'll go ahead and use English in this application. Now, before we start building our application, let's explain two important concepts in Lewis: intents and entities. An intent is the intention behind issuing a certain query, or what we call in Lewis an utterance. So, for example, in our travel application, a user might say, book me a flight to Seattle, in which case there is an intention to book a flight. One of the key problems in human-computer interactions is the ability of the computer to understand what a person wants in a given utterance, and to find the pieces of information that are relevant to their intent, which we call entities. So, to clarify, in our previous example, book me a flight to Seattle, that missing piece of information to our intent is the destination of the flight, which in this case is Seattle. So therefore, Seattle is our entity. So before we build our application, it is advisable to think about all the intents and entities that we will be needing inside the application. So in this example app, we'll have two intents, book flight and get weather. And as for the entities, we'll have date, time, and location. So we'll start by creating the intents in our application. The list of intents available in our application can be found on the top left corner. All applications come with one predefined intent, none. Create a new intent, book flight, and add an utterance, book me a flight to Seattle. You'll find that the example utterance that we entered is now in the labeling box and automatically labeled as book flight. As we mentioned before, one of the arguments of this intent is the location of our flight, which in this case is Seattle. So we'll go ahead and create an entity to detect our flight locations. In our case, locations can be of two types: source locations and destination locations. So instead of creating two different entities for both of them, we exploit the fact that they have much in common, and will leverage a cool feature we have in Lewis called hierarchical entities. Hierarchical entities allow us to add an is-a relationship to our entities. So in our example, we'll create two entities called toLocation and fromLocation, which are both children to the same parent entity, location. Now we can label Seattle as a toLocation type entity by highlighting the string that represents our entity. We'll go ahead and submit this utterance. Now, travelers using our example application might be interested about the weather forecast of their destinations. So we want our application to be able to detect inquiries about weather as well. So we'll create another intent, and we'll call that getWeather. Once again, we'll create an example utterance that will be labeled as the getWeather intent. So let's say, what is the weather like in Cairo? Once again, we'll go ahead and label Cairo as location, and we'll submit our utterance. Now, the more utterances we add to our application, the more accurate its predictions for intents and entities become. So let's go ahead and add a few more examples. So let's say, book a flight from Paris to London and we'll label the utterance as book flight and the entities Paris from location and London to location, and we'll submit that utterance. Let's go ahead and add another utterance for the getWeather intent. How's the weather in London? And we'll label London as the location and the intent as getWeather. Now let's add another utterance for booking a flight. The 30th of March. Now, since we're creating a traveling application, it's natural to have utterances that specify the date or time for booking flights. This is also another argument for the book flight intent. So naturally, it must be an entity. So for example, book a flight to Seattle on the 30th of March, we would like to label 30th of March as an entity with date time. Now, we could define a new entity here and teach it to recognize dates and times in this context. But luckily for us, Lewis offers a set of pre-built entities for commonly used terms such as date, time, numbers, temperatures, ordinals, dimensions, and more. So we'll go ahead and enable the date time pre-built entity. Now, rerunning this utterance, we'll find that Lewis now picks up 30th of March as the date time entity, which is good. And we'll go ahead and pick get book flight as the intent for this utterance, and Seattle as the to location. Now, periodically our model is automatically built. We can also click on the train button down here anytime to manually rebuild it. And what building does is that Lewis generalizes the examples we have labeled and develops code to recognize intents and entities to predict similar utterances in the future. Now there is a model present and we can investigate its performance. So now we can enter an utterance like, I want a flight to Redmond next week. Now this is an utterance that our application hasn't seen before. But with submission, we'll find that our application detects Redmond as the to location entity and next week as the date time and book flight as the intent, which is good. So we can see that this is classified correctly, so we'll go ahead and submit it. And these pre-labels or predictions accelerate our work, so we can go ahead and click submit without having to manually label every utterance ourselves. The final step we need to do is to publish our application to prepare our custom language model for public use via an HTTP endpoint. So let's go ahead and test the output of our application after publishing. Let's say I'm going to enter an utterance, I need to book a flight to Paris. Now, as you can see here, this is the JSON response with the highest scoring intent at the top and the entities detected in the utterance listed. So let's go ahead and try another example. So for example, let's try the query, what's the weather like in Redmond? And once again, we'll find that the highest scoring intent is at the top, and the entities detected are here listed, Redmond to location. The nice thing about Lewis is that all this supposedly user traffic, those utterances, are being logged, and all of them are available for improving the model. So let's go ahead and see how we can do that. We can interact with the unlabeled utterances that arrived on our HTTP endpoint via the Suggest tab. We can ask Lewis to suggest utterances for us to label that are most likely to improve the model, and we choose which model we'd like to work with here. So in this case, I'm going to choose the book flight intent. So these are the utterances that Lewis thinks I should label first to make maximum improvement to that intent. Now, this utterance is already classified correctly, so I can go ahead and submit it. Now I can retrain this model, and now we have the benefit of those additional labels. Let's show you another way of making improvements in Lewis. Consider this utterance: book me a flight to San Diego. So here Lewis picks out the word San as the to location, but not San Diego, the phrase which it should have picked up. So we could fix this and relabel it and add some utterances like it in order to train Lewis to detect two-word locations. Another thing we can do is that we can add a phrase list feature. A phrase list feature is a collection of words or phrases that Lewis should view as a class that in some context can be used interchangeably. So here we'll create a feature called city names. And we'll add Cairo, Seattle, Redmond, Paris, San Diego, London, and we'll go ahead and save that. Now the model has been retrained, and rerunning this utterance shows us that now Lewis picks out San Diego as the to location, which it should. And that's because we told it that these words or phrases are features and should be used as interchangeable. So in other domains, those features could be names of products, restaurants, people, and so on. So we'll go ahead and submit that utterance. So that's it for our demo. To summarize, we created an application, defined intents and entities, used pre-built entities to our convenience. We also added a few utterances to train our application. And finally, we deployed our application to an HTTP endpoint. And as utterances came in, we used them to improve our model via the Suggest tab. For more information about other features that Lewis offers, you can go ahead and click on the link that we have below, or visit www.lewis.ai/help. Thank you.